Welcome dear audience, students and scholars. Here I am Dr. Amjad Ali. In this video we are going to discuss measures of a position. Dear scholars, measures of position determines the position of a single value in relation to other values in a sample or a population data set. There are many measures of position, however, only quartile, percentile and percentile ranked are discussed in this particular video. Quartile and interquartile range. Dear scholars, quartile are the summary measures that divide a ranked data set into 4 equal parts. 3 measures will divide any data set into 4 equal parts. These 3 measures are the first quartile, second quartile and third quartile, that is normally denoted by Q1, Q2 and Q3. The data should be ranked in an increasing order before quartiles are determined. So for further understanding about the quartile and interquartile, let me give you the definition of quartiles. Quartiles are 3 summary measures that divide a ranked data set into 4 equal parts. The second quartile is the same as the median of a data set. The first quartile is the value of the middle term among the observations that are less than the median, and the third quartile is the value of the middle term among the observations that are greater than median. So for this purpose, here we have the each of portion contain 25% of observation of the data set arranged in increasing order. So our first quartile Q1, Q2 and Q3. So approximately 25% values in our ranked data set are less than Q1 and about 75% are greater than Q1. The second quartile is Q2, divides the ranked data set into 2 equal parts. So here we have 50% data is less than Q2 and 50% data is higher than Q2, and about approximately 75% values are less than Q3 and about 25% are greater than Q3. The difference between the third quartile and the first quartile for the data set is normally called interquartile range. So let me give you the formula for the interquartile range, that is IQR. The difference between the third quartile and the first quartile for a data set is called the interquartile range, that is interquartile range Q3 minus Q1. So for the further understanding about the quartile and interquartile, so let me give you an empirical example for this purpose. Here we have the data that gives us information about the 2008 profits of 12 companies selected from all over the world. Okay, we have to find out the interquartile range of this data set as well as the first, second and third quartile of this data set. So for finding the quartile of any type, we first rank the given data in an increasing order. So likewise we have the all data set in an increasing order. Here we have a mixed data set, but here we arrange the data set in an increasing order: 7, 8, 9, 10, 11, 12, 13, 14. 17, 17 and 45. So we divide the data set into two parts, that is value less than the median and values greater than the median, because we have even number data, that is 12 number of observations. So that's why we can divide data into two parts. And for the median or Q2, we know that we add the two central value, that is 12. I'm sorry. Okay, previously we have a little mistake. We have corrected this mistake, and that we adding 12 plus 13 divided by 2, and we get Q2 is equal to 12.5. That is our median as well. And for finding the Q1, because we are taking the central value of the less than median value, and we get the central point here, and Q1 formula look like that, 9 plus 10 divided by 2, and we get Q2 is equal to 9.5. and for getting the Q3, we can divide the greater than median data into two parts and get Q3 is equal to 14 plus 17 divided by 2, and we get 15.5. Okay, here the notable thing is that the Q2 is our median, as we have divided our data into two parts. So for the data of this example, the value is the average of the 6th and 7th. So here we have the average of 6th and 7th, and we get the median observation or median value, that is Q2, and we can say that Q2 is $12.5 billion. The value of Q1, as we have highlighted, that we can get the combination of third and fourth, and that is $9.5 billion. And for the Q3, we get the central value of that is 8th and 9th value, or 9th and 10th value, 9th and 10th value, and we get 15.5. That 15.5 represent the $15.5 billion. So the value of Q1, that is 9.5 billion, indicate that 25% of the company in this sample had profit that is less than 9.5 billion, and 75% of the companies had profit that is less than 12.5 billion, or sorry, higher than 9.5 billion. So similarly, if we state that half of these firm had a profit is 12.5, so we can say that half of the firm have less than $12.5 billion profit, and half of the firm has $12.5 billion is higher than. So likewise, if we are using the Q3, and Q3 value is $15.5 billion, that indicates that 75% of the companies had profit less than 15.5 billion, and 25% firms have greater than this profit. So by looking at the position of 8 billion, which is here you can see that 8 billion, which is 2008 profit of this particular firm or company. So we can state that this values lies in the bottom of 25% for 2008. So likewise, if we are taking the value of 45, so this indicates that we have the higher rate of profit. So for the interquartile can be taken as the difference between higher quartile minus a lower quartile. So we have the higher quartile Q3 minus Q1, and that is 6 billion answer. So for the further understanding about the quartile, so let me give you another example for this purpose. Here we have the data, that is the ages of 9 employees of an insurance company. The age is given as 47, 28, 39, 51, 33, 37, 59, 24, 33. So we have to find out the 3 quartiles and provide the information that what is the value of interquartile range. So first we have to arrange our data in an increasing order, and we can divide the data into 2 parts. Here we have the odd number of observations. In our previous example we have the even number of observations, so that's why we have divided our data into 2 equal parts. So here we have the odd number of observations, so that's why 37 is not included in the values greater than median, not included in the values less than median. So that's why our Q2 is equal to 37. But for getting the Q1, we have to add 28 plus 33, and we get Q3 or Q1 is equal to 30.5 years, and for Q3 we have 47 plus 51 divided by 2, and that is 49 years. Thus the value of these 3 quartiles is Q1 is equal to 30.5 years, and Q2 is 37 years, and Q3 is 49 years. The age of 28 falls in the lowest. Here we can say that age of 28 is in the lowest 25% of the ages. So for finding the interquartile range, we have the interquartile range formula, that is Q3 minus Q1, and we have Q3 49 minus 30.5, and we get interquartile range that is 18.5 years. Okay, let me give you further explanation about the percentile and percentile rank. Dear scholars, the percentiles are the summary measures that divide a ranked data set into 100 equal parts. Each ranked data set has 99 percentiles that divides it into 100 equal parts. The data should be ranked in an increasing order to compute percentile. The kth percentile is denoted by pk, where k is an integer in the range 1 to 99. For example, if you want to find out the 25th percentile in the data set, you can write that p subscript 25. But let me give you the definition for the percentile. So here we can see that each of the data set can be distributed into equal 100 parts. So for each, these portions contain 1% of observation of a data set arranged in an increasing order. Thus the kth percentile pk can be defined as the value in a data set that about k% of the measurements are smaller than the value of pk, and about 100 minus k% of the measurement are greater than the value of pk. So for the approximate value of the kth percentile can be determined like as calculating the percentile. The approximate value of the kth percentile denoted by pk is pk. Value of the kn divided by hundredth term in a ranked data set. So here K denotes the number of percentile and N represent the sample size. So for the further understanding about the percentile and percentile rank, let me give you an empirical example for this purpose. So here we have the data of 12 companies profit that is 7 billion, 8 billion, likewise we have discussed in our previous example. So first from the previous example we borrow the data and we have our data in an increasing order. So for finding the percentile or quartile, we have to arrange the data in an increasing order. So we have arranged the data in an increasing order. So we have to here find out the 42nd percentile. So for the finding the 42nd percentile, we have Kn divided by 100, and K are required is find out the 42nd number, that is 42 into 12. We have the total number of observation is 12 and divided by 100, and we get the answer, that is 5.04th term. So here we can see that the value of the 5.4th term can be approximated by the fifth, because our number after the point is less than 1, so that's why it is here 0.04. So that's why our fifth term, or we can approximate it to our fifth term, or round off to our fifth term, that is 11. So our P42 or 42nd percentile is equal to 11. So our answer will be 11, and 11 represent the 11 billion. That the approximately 42% of these 12 companies had profit less than or equal to 11 billion. So we can calculate the percentile rank for a particular value of a data set by using a formula of the percentile, that is let's see, percentile rank of any observation, that is xi, is equal to number of values less than xi divided by total number of values in a data set multiplied by 100. So for the understanding about the percentile rank value, let me give you the empirical example for this purpose, and we are using the same data of 12 companies profit in 2008, and we are arranging the data in an increasing order, and we are going to find out that 8 of 12 values are less than 14 billion. So hence our percentile rank can be written as 14 rank of percentile rank of 14 is equal to 8 divided by 12 multiplied by 100. So if we want to find the percentile rank of 14, so we put it 14 here and count the less than observation of 14, that is 1, 2, 3, 4, 5, 6, 7 and 8. We put it 8 and then divided by total number of observation multiplied by 100. And if you want to find out these answer of percentile rank of this 17, so you can count these number of observation, and if you find out the percentile rank of this 17, you can count the number of observation from less than this 17. Okay, so the answer shows that 66.67%. So rounding this answer to the nearest integral value, we can state that about 67% of the companies in these 12 had less than 14 billion profit. Hence, 33% of these 12 companies had profit higher than 14 billion. So this is all about measures of position with the help of quartiles, interquartiles, and percentile ranks. So see you with another video. Ciao.